Okay, good afternoon, good evening, everybody. Welcome to the Distinguished Business Analytics Speaker event. This is our third online session talk organized by INFORMS Southeastern Michigan Chapter. I would like to thank you, my colleagues, Jason, Sarah, and Oleg, for putting efforts in planning, organizing, and coordinating these events. My name is Ahmed Zubani. I'm the Secretary Officer of the INFORMS Southeastern Michigan Chapter and also the Assistant Professor of Decision and Information Sciences at the Oakland University. Today, it's my pleasure to first introduce our speaker, and then he starts his presentation, and after that, as Jason mentioned, we will have a couple of minutes for Q&A. You can send your questions by messages, and Jason will collect those and read to the speaker, and he will answer them. Our speaker is Mr. Alan Jacobson, Chief Data Analytics Officer of Alteryx. Alan leads the company's data science practice as a best-in-class example of how a company can get maximum leverage out of its data and the insight it contains. He's responsible for data management, governance, products, internal data, and use the Alteryx platform to drive continued growth. Prior to joining Alteryx, Alan held a variety of leadership roles at Ford Motor Company across engineering, marketing, sales, and new business development, most recently leading a team of data scientists to drive digital transformation across the enterprise. Alan earned his bachelor's degrees in engineering from University of New Hampshire and received his bachelor in mechanical engineering from Virginia Tech. Today, Alan will talk about the analytics in turbulent times. He tried to answer questions such as how have analytics helped solve company as well as societal issues from pandemic to day-to-day operational challenges. He will cover example of how analytics have come to the rescue and see how companies and government agencies around the world are rapidly shifting to the analytic process automation platforms to drive digital transformation in their businesses. Again, thank you so much for attending, and thank you so much, Alan, for accepting our invitation to talk about such an interesting topic. Time is yours.
Thanks very much for having me. I look forward to the next hour or so together. Hopefully, we'll be able to be interactive. Again, you can unmute your line. I'm going to try to ask some questions as we move through the material. Hopefully that makes it even more interesting than if it was a one-way talk. I'm going to speed through some PowerPoint and then maybe switch to actually playing with some analytics using Alteryx for those who haven't gotten to see what Alteryx looks like. That'll give you kind of a firsthand experience of what this tool allows you to do. So let's dig in. So I'm going to first rewind in time and talk a little bit about analytics in the past. And so this gentleman, I have a lot of thanks for what he did for analytics. Does anybody know who this person is, by the way? We'll start off with a question. You can put it in your chat message if you'd like. No guesses? So this gentleman was one of the first to use geospatial analytics. There have been a few others earlier, but a great example of geospatial analytics. What you see in the background here is a map of London, and the bar graphs, or the little bars you see on the map, are the number of times that people were impacted by the cholera epidemic. It's a map of downtown London, and this is John Snow. It's 1854. And the cholera epidemic was taking many lives. It was a global pandemic, and he was dealing with it in London. And this geospatial analytic that he created very quickly isolated the cause of the pandemic in London to the Broad Street pump located here with all these bars around it. And he used this geospatial analytic to help the mayor of London agree to take the pump handle off the pump so that people would no longer get infected by the disease. And that basically brought an end to the cholera epidemic in London. Now, the interesting thing here, I think, is what John Snow's profession was. Any guesses on his profession? Well, you guys have to unmute. It won't be fun if there are no guesses. You think it was a statistician, data scientist, operations research, a member of INFORMS? No guesses?
Was he a doctor?
A doctor, right. He had domain expertise. And this is frequently a key ingredient, we believe at Alteryx. This is a key ingredient to being able to really implement powerful analytics. It's the combination of some domain knowledge, in the case of trying to fight a pandemic, having a medical background. He was an obstetrician, actually. And combining that with some statistical knowledge, some analytic knowledge, which clearly he had creating this geospatial map. He had some savvy of how to look at numbers and look at data to help solve problems. And it's that combination of those skills that made him able to do this. And we think that that's very important. And so when we, again, look back in time and look at the changes that have happened, when I look even back over my career over the last 20, 25 years, a lot has happened. The computers that we now are blessed with having in our possession, our laptops, they are typically around 10,000 times faster than the computers that I started my career with about 25 years ago. Not only are the chips faster with Moore's law, but on top of that, we have more chips. The computer that I'm running this presentation off of has 16 processors running, so it's very parallel processed, and the chips are quite fast, and it has a lot of RAM. And so the speed difference is about 10,000 times faster. And in addition to that, the programming kind of languages and libraries have changed. Again, when I started my career, R and Python were just born as languages. Now these languages have millions of users and hundreds of thousands of packages that I can draw from. So if I need to build a neural network at the beginning of my career, I would have had to written the entire neural network. Here I can, use a package or a drag and drop tool that'll do that for me. And so the speed at which I can do my analytics, again, very different than it was at the beginning of my career. And again, over that short period of time, the amount of data that's available is much, much larger. We have data pipes to be able to transfer it at much higher speeds. So at the end of the day, a lot has changed. Now, what does this mean? Well, it means if we're asked to solve a problem, answer a question, and today we can go 10,000 times faster than we could just 15 and 20 years ago. What this means is that if I get asked a question and I try to solve it like I used to solve it, I'd be going maybe 3 miles per hour, the speed of this baby. But sitting on my desk, armed with R and Python and modern day compute and all the data that I have, I could be exploring the data and solving the problem at 10,000 miles per hour or 30,000 miles per hour, the speed of a high-speed jet. And the real question at the end of the day is, does everybody actually know how to pilot the jet? And that's at Alteryx, what we're really passionate about is delivering a product that everyone can use, whether you're a data scientist or a business analyst. It's easy enough to use that everybody can fly the plane. Everybody can do the analytics. So people with domain knowledge can spend their time applying that to solve problems. And so our mission is easy to use software along with the appropriate training and support to have people be able to be successful doing that. And so we find people are doing just that. They're upskilling in their training. We have very young kids basically learning how to use Alteryx, as well as people that are mid-career learning how to use it and solve huge, huge real-world problems. The next issue that people run into is this difficulty of making actual digital transformation happen. So now that maybe you can do the analytics, how do you actually implement them within a company? And here we've seen over time 3 significant waves of change. About 10, 15 years ago, if you went to a conference about data and analytics, most people were talking about data, building data lakes, how much data that they had. Do you have a terabyte? Do you have a petabyte? It was all about the data. And the leaders that were leading this effort frequently came out of the IT organization and fundamentally weren't necessarily change makers. They were governing their data stores. And in a second wave, I'll call it 1.5, the talk track changed. If you went to a conference maybe 10 years ago or 5 years ago, somewhere in that range, people were starting to talk a lot more about analytics. What type of analytics are you doing? Are you using deep learning? Are you using a neural network? It became a little less about the data and a little bit more about the analytics. And even the titles changed. We saw CDOs, Chief Data Officers, in the first wave, and now we were starting to see Chief Analytic Officers, or what became Chief Data and Analytic Officers, a merged title of the two. And people were becoming much more focused on doing something with the data, leveraging analytics. And now kind of the current wave that we see that we're on, what's happening is people are caring less about how big the data is, and they're caring a little bit less about how fancy the analytic is. The real question is, are you making an impact? Are you ending a pandemic? Are you solving a real business problem? What's the return on investment is becoming more the conversation than fundamentally how fancy is the analytic. And in this wave, we again see titles starting to change. Many companies are putting chief transformation officers in place. They're talking a lot about human-centered design. They're working to upskill their teams to take advantage of analytics. So this has changed a lot in recent history as well. And so again, another person from history, anybody familiar with this person? I think it was Janelle who had a great guess on the last one. I'm not going to pick on Janelle.
Nightingale.
What's that?
Florence Nightingale.
Yeah, Florence Nightingale. Again, similar period of time, out of London again. So two, I would say, great data scientists out of London. But again, her profession wasn't a data scientist. She didn't grow up learning, statistics in school. She was a nurse. And the problem she was trying to solve was the problem shown here in the graph in the upper left-hand corner. Many people were dying in British Army field hospitals in Crimea. There was a war going on, and you can see in this radial graph here the number of deaths, and this was about 40% of the people going into the Army field hospital were dying. And most of them not of wounds. The gold markings are people dying from battle wounds. Most people weren't even dying from battle. They were dying because they just got sick, and they went to the hospital, and they weren't making it out of the hospital. Certainly, this is not a place that you would want to go if you got sick. And Florence was amazing at collecting data, analyzing it, and then from that, deciding what best practices really worked to stop the spread of disease. And you can see a sharp cutoff here where the mortality rate changed significantly as she implemented those practices here in April of 1854, and the death rate went dramatically down. Many of these practices are used today. They're what we're actually talking about in today's pandemic, things like washing your hands. At that period of time, a lot of people thought that disease spread was from smell. They didn't realize that sterilizing and washing hands between each patient would make a huge difference. And so at the end of this, she basically had proven that these techniques worked, and the Army field hospitals in the Crimea were actually safer than many of the hospitals in downtown London at the time. Huge impact made, again, by a domain expert with data science skills, with analytics skills, collecting a ton of data and analyzing the data. And what you see in both of these cases, in the case of John Snow and in the case of Florence Nightingale, what they needed to happen is for change to happen. They weren't just collecting the data and presenting a PowerPoint. They were trying to actually make an impact, get people to change what they were doing. And it turns out that change is pretty hard. And so there were two great studies, one by McKinsey and one by Forbes, that studied change. And they found that most change efforts are not successful. Does anybody have an idea of what the success rate is? If you went to a company, this is their self-assessment, and said, what % of your change efforts work? What percentage do you think that they would say? You can type an answer if you want, or unmute, either way. So 1%, boy, that would be pretty dismal if only 1% were successful. That'd be terrible. It is pretty
20%?
depressing. What was that?
20%?
20%? Yeah, you're pretty close. So it turns out that in McKinsey's study, they found 70% of transformation efforts fail. And they were studying business transformation, not specific to digital transformation. And then Forbes came behind them and looked at digital transformation, did a very similar study, and they found that it was the same. It was the same 70%. What this tells us is that the digital part isn't necessarily, I guess, good news, making it harder. It's also not necessarily making it easier. Change is hard, whether it's digital or not. Humans have a tough time with change. And so one of the key things we find is that it's one thing to have analytic capability, it's one thing to know how to use analytic tools, but what you also actually have to be pretty good at is this change management piece. And this is something that Florence Nightingale and John Snow were quite good at. And it's a pattern we see at companies all over the world, that it's being a change agent, somebody who can help make change happen on top of the analytic capability that really is quite important. And so from our experience, it's this combination of data, process, and people. Upskilling people, helping them get through that change management process. It's the data, actually having data that can answer a question and be able to automate processes and apply analytics to them that make a huge difference. And at Alteryx, we're used by about 40% of the global 2000, and we're used in all sorts of different areas. And so these are some of the use cases shown on the screen that companies all over the world use us for. Fun stuff like sports analytics, or major retailers trying to figure out where to locate the next store that they open, doing net promoter scoring, optimal pricing, auditing, all use cases that people leverage the platform for. Now, the other thing that we've seen in surveys, and this is from Harvard Business Review, is that a majority of the organizations in the world, 63%, today rely on IT or an analytics team to do the analytics. It's not people like John Snow or Florence Nightingale. They would have to send their data out for somebody else to analyze it, which is certainly not what John did, nor what Florence did. And it's interesting, still today, none of these people reported satisfaction with that process. It turns out that domain experts being able to look at data themselves and manipulate the data is where a lot of the learning occurs. And sending it over the wall to somebody else to do the analysis typically is not something that leads to success. And so again, for us, it's very important to give tools to people that have that domain knowledge to let them do the analytics. And we see this at companies all over the world. We have examples with airline companies doing things like fuel loading analysis to understand the optimal fuel levels to put in planes and how much fuel to buy in different geographies. A large big box retailer that you may have been at this weekend buying gardening supplies, they had a person who was responsible for inventory management build a model to automatically optimize pricing and discounting to optimize the inventory levels. Saved over $177 million with that workflow. And that was the person that was responsible for inventory that did it. And we see these examples again and again at many companies all over the world. And so I'll share this one example. I think this is a great combination of these different elements. And it's a US government example. After Hurricanes Irma and Maria that hit just weeks apart from each other, did incredible damage to several Caribbean islands. There were over 146,000 structures, houses, businesses that were damaged. And the normal process that FEMA uses to assess these buildings is you would send out a team of engineers to every one of those structures. And one of the key things they have to assess is whether the damage is over 50% or under 50%. If there's minor damage, if it's less than 50%, they allow them to rebuild to the same code because it wasn't significantly damaged by this major hurricane. If the damage is over 50%, then the rebuilding must be to a higher code. And so at the end of the day, doing these assessments very quickly becomes important because you can't rebuild until the assessment is done. Now you can imagine doing 146,000 assessments with teams of 3 engineers could take a long period of time. The initial estimate, if they would have done this the way they normally do it, it would have taken over a decade just to assess the structures. Clearly not something that would work. And so the team of experts flew into the islands in the Caribbean, armed with a laptop computer, a backup battery-powered power supply that they could power the computers with, and Alteryx running on it. And they built models to assess the damage. So they sent teams out to assess some random buildings. They then built models to correlate the damage to wind speed, weather reports, a bunch of other data that came in from, I think, 7 or 8 different agencies, including weather, satellite information, wind speed, surge, rain, depths, et cetera, and built these models very quickly. And that took huge amounts of time off the recovery effort. And now this is how we respond to disasters going forward, or with these modeling tools. So a little bit about Alteryx, and then I can jump into a demo for you. Alteryx has been around for 27 years, so quite some time. As I mentioned, used by almost 40% of the Global 2000, right now at 37%, 6,400 companies leveraging Alteryx. One of the key statistics is that 70% of the people who use the platform self-learn. It doesn't require extensive training in order to be able to get up and running. In fact, 80% of our users deliver an ROI, a return on investment, in the first 2 weeks of using the product. 140% net expansion, showing that customers that are leveraging the platform are able to grow on the platform year over year. They continue to expand and have more success. We're used in pretty much every industry and every domain. So these are just some examples of some of the industries that leverage Alteryx today. And they typically use Alteryx for efficiency gains, top line growth, bottom line return, or to upskill the workforce. So what does Alteryx do? Fundamentally, you can take data from over 80 sources, do data profiling, data blending, diagnostics, prescriptive and predictive analytics, full AI capabilities along with geospatial analytics, and you can publish the results out, whether you publish them into a report or you publish it by pushing data back into an enterprise application or through an API, or you can put it into a BI application, a dashboarding tool or something of that sort. So from anywhere, perform the analytics and push it to anywhere. Alteryx is this analytical process automation layer in the middle that allows you to apply those analytics. Some of the capabilities include data prep and blend, where you can drag and drop, cleanse your data, interactively explore it with visual profiling of your data, enrich the data, do things like the geospatial analytics. We have data sources built into the platform with TomTom, so we can do things like drive times between locations automatically within the platform. We also have Dun & Bradstreet and Experian data built into the platform, so we can do very powerful demographics and firmographics as well. And then on the data science side, a full suite of AutoML, predictive and prescriptive analytics. So whether you're doing linear programming or quadratic programming and optimization, whether you're doing a machine learning model, a neural network, all of this can be done in a drag and drop way. Or if you do wish to code, we have Jupyter Notebooks integrated in, and you can code in those languages within the platform as well. And these are some of the use cases that we see by domain. So if you look in the office of HR or in the marketing office, you can see the types of use cases that people leverage Alteryx for. But we're at about the halfway point. So what I thought I would do now is switch gears and switch to a demo of Alteryx itself. I did get one question come in about university partnerships. And yes, we do make it available for universities for classroom use for free, no charge. So not only do you have use of the software, but the complete training platform as well. So great question, Vijayan. Appreciate that. If there are questions about how to obtain those free licenses, be happy to discuss that at the end as well. So on the screen, I have Alteryx here on the right side of the screen, and I've got some folders here on the left. I'm in my Analytic for Kids folders. I've got an 11 and 14-year-old. They are both certified in Alteryx. So yes, this is very easy to learn. They can do things in Alteryx that it would actually be pretty hard for them to do in Excel or some other tool. So let me shut these notifications off. Hold on one second. Can I shut that off? There we go. All right, so I'm gonna go into my education and income folder, and actually the models that I have here, I asked the kids to predict crime in the US. That's a little depressing, so we won't do crime. We did who was gonna win the Women's World Cup, but we already know that answer, so no fun again. And then here, my son is trying to figure out what factors help make him run faster. He's training and running, and he's trying to figure out, should I run late in the day, early in the morning, before I eat, after I eat? So we were building models to figure that out. But I'm going to do an education and income example here. And the question that I asked my kids, and I'm going to ask all of you, if we know education by country, I just downloaded this file off the web. It's an Excel file. If I know education by country, I'll drag that file in. And this is a really simple file that shows countries and standardized test scores on reading, math, and science here. So you can see the data here. And if I know income by country, so I know per capita income by country, this is a CSV file, again, right off the internet, country names and per capita income. So if I know income and I know education, do I believe these two things correlate? Do I believe that maybe doing better in school might correlate to making more money? And then I also asked them if more women are able to work in those countries, do we think that correlates to income? And if there are more patents in the country, more creativity, you might argue, does that correlate to income? So first, for those on the phone, what do you guys think? Again, you can use your chat panel, or you can unmute yourself. Do we think education correlates to income? Of course not. So I have one, of course not. I would be a terrible dad if if these things didn't correlate. Because I'd be teaching them not to study for the test. So indeed, these things actually do correlate, and they do positively correlate. So a few of you are getting that guess correctly. And again, it's okay, it's a guess, it's a hypothesis. So we do believe at Alteryx that you should follow a data science process, which is a part of the part of the scientific process. You should start with a hypothesis. So I encourage everyone to guess. It doesn't matter if you're right or wrong, it's a hypothesis. So we have education, we have income, and now we're gonna try to do this analysis, right? And so the first thing I'm going to orient you to at the top is we have many folders that have different types of tools in the folders, and then down below that we have actual tools themselves. So the first thing I need to do is bring this data together. And I'm assuming, since this is INFORMS, most of you on the phone are way past Alteryx, or way past Excel, and most people on the phone program in R or Python and know a thing or two about databases. So if I was in a database and I had two tables and I needed to combine them, what would the command be? Any guesses? A join, very good. Jing's got it, and Vijayan got it. Okay, so at the top we see these folders, and I can see there's a whole folder of ways to join data. I can union them, join multiple, a straightforward join, which is what we'll do. I can fuzzy match. Maybe the names don't exactly match each other. Many different ways to bring data together. And I can also join them to databases that we have in the software already. So I can match them to business addresses in the US or some consumer information from Experian. But I'm just going to do a straightforward join on this data and join these two files together. And the first question it asks me is, what do I need to join them on? And indeed, I want to join them on country name. And it saw that both files had that column, so it automatically did that for me. And so now I have joined these two files together. And you can see here with these Venn diagrams, I have three outputs on the screen. I'll make this a bit bigger. Three outputs. Out the center output, you can see by the Venn diagram here, is the inner join, or where the countries match in the two files. The L at the top. Again, with the Venn diagram, I can see that the countries in the top file that are not in the bottom file, they're all going to come out this L here. So hopefully that makes sense to everybody. And while I'm at it, I can do the other sorts of things we usually do when we're cleaning up data. Maybe I want to change the names of the columns. So I'll just rename some columns. Maybe I want to change a data type. So I noticed down here at the bottom, the per capita income, it came in as a string because it was a CSV file, and I need that to be a number. So I'm going to switch that to a number. So I just did 3 different joins. I renamed 4 variables, and I changed the data type on 1. And I probably could have done that very easily in Excel or Python or R or SQL, any of those tools, certainly you can do it. You're going to get the same answer in all of the tools. I would argue that you probably cannot do it as fast as I just did it in any of those tools. And more importantly, what I'm building here is a process, a flow that I can actually put on a schedule or trigger with an API. So I'm building basically an application as I'm doing this, which is another very powerful feature of the platform. Now we have all of the data preparation tools that you're used to. So in the data preparation tools, whether you want to write a formula, just like you would in Excel, I can bring a formula tool down, and we have all of the functions and formulas that you're used to seeing in SQL or in Excel or in some other analytic package. But we also have R and Python integrated into this as well. So I'm going to do an association analysis, basically linearly regress these variables against each other and see, do I see any correlations? And so I'll bring down this R-based tool. You can see the R logo on it, but I don't actually have to code any R if I don't want to. And I can just hit run, and now it's going to pull the latest data in. If I were connected out to the web, it'd be grabbing the latest data in from the web. It joined them together, and it built me a correlation matrix. So here I see the correlation matrix. And again, it shows in words, but the darker the red, the more positively correlated. Dark blue would be negatively correlated, and white would be scatter. So here I can see for income, reading's a 0.39, science a 0.41, and math is a 0.44. So the most positively correlated is math, and I can see that all of these actually are positively correlated. But really interesting, I see this dark red box, 0.97, math versus science. I click on it, I can see the scatter plot, indeed very linearly correlated as the math scores are going up. So are the science scores. It certainly makes me wonder why we need to take both tests. Any idea why we take so many tests? Like the test industry clearly hasn't figured this out. Actually, they probably have figured it out. They hope we don't figure it out because they like to charge by the test, I guess, because this test doesn't seem to be adding a lot to the equation here. And this is what we can do very quickly and easily, these basic analytics with these very drag and drop quick methods. So I'll pause for a second. Any questions? And Janelle's spot on. They want you to do this for the money. I love it. So I'm going to delete this. And maybe we actually just want to build a model, a predictive model. These are some R-based models. I'll look here first. We could do support vector machine learning, build a neural network. Maybe we just want to do a linear regression. Simple. It's much like I just did in that associativity analysis. Again, I drag and drop the tool. I can tell it's the R-based linear regression. What am I trying to predict? It's got to be a numerical field because this is a regression. So it can only be one of these fields. I want to predict income. I want to predict income with reading, math, and science. And congratulations, we have just built our R model. And now to use the model, we need to pull down a scoring tool. The scoring tool now knows it's looking for 3 inputs, reading, math, and science. And as long as it sees those 3 columns, it's going to then append to the data set an extra column, which is going to be the score, which is going to be its approximation of income using this model. So I'll use the inner join here. And again, this isn't proper model building technique. I could sample down the data with a sample tool and run 80% through the model build and hold 20% back for holdout. Here I'm just overly simplifying to give you a sense of how the platform works. We'll take a peek at the results. And then just for fun, I'm going to stick a browse tool here and hit run. And so now again, it's grabbing my latest data. It's redoing the join. It's building my model, scoring it. And now we can take a look at the output. So down here at the bottom, and my screen a little bit. We'll click on the output here. And I can see for Argentina, here are the reading, math, and science scores. It joined that up with the other file. So here's the other file. It's an exact match. I wasn't doing fuzzy matching, so of course the names match exactly. The actual income in Argentina is 20,784, and the prediction just using reading, math, and science scores, so not a great model by any stretch, is 24,459. So really quick way to build a model and see how it's performing. And again, when I built the model, I can get all the normal R outputs and look at the statistical behavior of the model, the t value, the p value, standard deviation, all those sorts of things are provided as well. So I'm gonna, again, pause for a second. Any questions so far? Are you guys having fun? They're so quiet. So there are many other capabilities in the platform. We have prescriptive tools where you can do things like simulation and optimization. So in the optimization tool, you have many objects and many options, linear programming, mixed integer, and quadratic programming with a couple of solvers built in. So you can do some optimization work if you wish. We have geospatial capabilities to be able to understand things like trade areas, drive times, and geospatially join data together. A full reporting suite where you can output the data in interactive charts and graphs with full layouts that you can then automatically email to folks. And then once you've got the workflow that you want, you might want to output the data. And so then we can drag an output tool down to output the data. And much like the input, you can output it in any format you want, anywhere you want. So again, typically you're not storing the data into Alteryx. You're able to store the data anywhere you want. Now, at the end of the day, maybe you want to code. Maybe you are familiar with how to code in Python or R. So I could, if I wanted to, drag down a Python tool. It'll open up a Jupyter notebook for me. I can program some in Jupyter. And again, I can intermix these tools. So I can do some drag and drop where that's easy and fast. And then I can flip and use the open source ecosystem, writing code in Python if I wanted to. And so there was a question, are there open source competitors to Alteryx? Indeed, obviously you could write this all in Python using open source libraries or R. It would take you much longer. It would be harder to maintain than the code-free way of doing it. But certainly, all of this at the end of the day is math. You can do all of this analytic in paper and pencil. You could do it with an abacus if you want. It's all math. You'll get the same answer. You could program it in C. So there are some different options out there. The reason 37% of the Global 2000 use this, it's very fast, it's very easy. Whether you're a data scientist or an analyst, when you have use cases where you can use a tool like this, most will find it's very fast and easy to use, faster than they can do it in other tools, including competitors that are in this space. The other reason people leverage our platform is that the engine used to do the computations is incredibly fast. You can do billions of rows of data on your laptop, unlike many other tools. So very scalable for very large data sets and very fast, much faster than pandas and Python would be doing it in a more open source way. Even if you leverage Dask, we've done time trials, our Alteryx engine is much faster than using those methodologies. In addition to these capabilities, we've just launched our text mining suite where we have OCR and NLP capabilities. So whether it's topic modeling, sentiment analysis, OCR of a PDF file, all of those are built in. And we also have a machine learning toolkit where we can basically perform auto modeling. So instead of you picking what models to use here, you can bring in an assisted modeling experience, type in the data into the assisted modeling experience. I'll get rid of this other piece of the workflow just to make it easier to read. I'll hit run. We're priming the assisted modeling tool. We'll go ahead and start it up. And here, it will help walk us through the process, imputing any values, doing the hot encoding, running the different appropriate models that we might want to use. So here it looks at all the data types. We tell it we're trying to predict income. It automatically says that is a regression problem, not a classification problem because it's numerical. It selects the appropriate models to run through, tells us what features we should probably drop versus which features we should probably keep. So a little bit different looking than the other experience. Go ahead and hit run. It looks for any missing values. It would recommend imputation techniques if we had missing values. Tells us what the good predictors are, runs a number of models, and then starts building a leaderboard of how those models perform. So again, I'll pause. Any questions so far? We're just about towards the end of the time. I did want to keep this open for Q&A. I do see one demo or one question in the chat window about are all of the packages developed ourselves or do we integrate with partner tools? It's a phenomenal question, great question. So I'm going to give kind of three different legs to this. Certainly there are tools in our palette that are totally proprietary to Alteryx. You know, we've built them. They're not based on R Python. It's a tool that Alteryx built. We also leverage best-in-class open source libraries. So for sentiment analysis, we leverage things like Vader, or for OCR, Tesseract as an example. And so we do leverage best-in-class open source, and you're able to import into the tool any open source libraries you wish. So I see someone asking about, for deep learning, such as CNN and RNN, how much support does the environment provide? Again, any R or Python-based package you can bring into the environment. And then we have an entire ecosystem where people have developed their own tools. And so if you would like, you could actually build your own tool, your own icon. You could go out and get an RNN package that you like, find a pretty icon, design what your inputs and outputs are going to be to leverage that package. And you can actually create your own tool on top of the platform. And you could do that just for yourself, or you could actually do that to share within your company, or you can monetize that. You could sell that as part of our marketplace, if you will, and sell it to people who want to use your tool. So we have over 16,000 tools that have been built by the ecosystem, leveraging whether it's open source or their own proprietary items. In terms of installing the product, somebody just asked, can you install it on Linux? And I assume you're specifically probably asking about an Apple machine, Apple OS. So this is a Windows-based product, but many on our team do use Mac OS, and we do it in Parallels, or we do it in Boot Camp. So it will run on a Mac, but you're running it in a virtualized environment. Great questions, by the way. Any other brave souls to either ask a question, or if you'd like, you can come off of mute, and we can do it that way as well. So different not being in person with everybody. I haven't adjusted completely.
I have a quick question.
Yeah.
So Alan, can you share what would be best practices to maintain an Alteryx model or tool after you developed it?
Yeah, I'd love to talk about that for a little bit. And I think the answer that I'm going to give is not specific to Alteryx. So I'll give a couple sentences on what kind of Alteryx offers in this space. We can deploy models on our Alteryx server, on your desktop. We actually have a Promote product that does just model management. It's a high availability, low latency platform to just do model management. But separately, I'm seeing a trend kind of in the data science world, and I was actually gearing up to write a blog piece about it. I'll share it with the team here. I'm curious if anybody is leveraging the techniques that I'm going to describe here in a second. But one of the things I'm finding is, because you can build this automation and create a pipeline to rebuild models anytime you want, the old practice that I saw many companies use is they would build a model, and then maybe once a year or once a quarter, they would check it to see if it was performing within the limits that they wanted. And as long as it was within limits, they didn't change the model. It just stayed the same for time. Now, because it's so easy to rebuild models every day, every hour, so that it's always using the latest information and adjusting based on the latest information, I'm seeing an ability now to shift from monitoring a model every day or month or quarter or year to rebuilding models really on the fly. And then instead of simply looking for things like model drift, what you're really doing is checking that the model is still following all of the parameters that you want it to be within. And as long as it's within these parameters, you're allowing it to update. And if it's not within those parameters, you're notifying the human in the loop to say, look, new data has come in that's significant. It's telling you that you really do want a different model, but it's outside of the normal parameters. You need to take a look at this before you release the next model. And that's very different than the historical way people have thought about doing model management. But with these automation pipelines that can rescore the data so easily, that's really becoming a new way that people are looking at this. Does that resonate with anybody? Has anybody moved to more of a real-time training that as new data comes in, you continuously retrain your model? I see one yes.
Yeah, That makes sense to me. I think you're right. It's a combination of both. Sometimes it's the data scope could change, or it could be another input we didn't put into the previous model version, and then the model itself needs an enhancement.
Yeah, I mean, there are many good reasons why, in some cases, people don't want to change the model because maybe humans understand the model, and if you're changing the model every day, it becomes hard for the humans to understand what just changed, and so it's too much retraining. There are other cases where the humans really don't care about the details of the model. They just need the best answer possible. But it's very important that you're monitoring it. And someone brought up the point, you have to be careful about overfitting. And it's not just overfitting. I mean, if new data comes in, I'll use the pandemic as an example. During this pandemic, I was called in to many different companies and government agencies trying to help them do analytics to react to the pandemic. And part of the problem is the conditions in the pandemic were so different than the historical data, your historical models probably weren't working anymore. And so figuring out how to quickly build new models with the latest data became very important, but it's not a trivial exercise. And if you were doing something in a very continuous way where the models kept rebuilding, they could have maybe accurately adapted, or they could have gone completely off the rails depending on how they were built. Maybe they didn't have the right features, they weren't set up correctly for the pandemic, in which case you need a human in the loop. So in either way, you need monitoring. It's just very different type of monitoring in those two situations. So someone mentioned SAS provides a similar model management and deployment capability. Indeed, and there are other companies that are in this space. We certainly have people that compete in certain niches. One of the key differences that we find with SAS, with many customers who use SAS, is that it takes typically a fair amount of time to learn SAS, and SAS is typically not used by everyone in the business. It's not easy enough for an HR professional or a marketing professional to use it with these drag and drop methods. And so in general, SAS is only typically used by the statisticians and the data scientists, versus Alteryx is really used by kind of the full spread of users, from data scientists all the way to analysts. And that's one of the biggest differences. Responding to in the chat window, Vijayan had made that comment. In terms of big data, Ahmad asked the question, does it handle big data and analytics? He mentions MapReduce programming models. There are a few ways that we handle big data. So first, I already told you that the engine, the proprietary engine that we process data with, is geared to handle very large data sets, billions of rows, not a problem with Alteryx. In addition to that, we have in-database tools that allow you to process the data where it sits. So if you have a lot of data, let's say, sitting in a very large database, you can bring down an in-database tool, any of these tools. So maybe I want to do my join in DB, in database. So if these two data files or tables were sitting in a SQL database and it was a terabyte of data, I don't necessarily want to bring all that data to my laptop just to get the inner join out, because then I'd have to move a terabyte of data. So all these in-DB tools let you harness the power of where the data sits, connecting with pretty much all the major technologies to do in DB. The beauty of this is you don't now need to know the syntax for doing a join in Oracle versus SQL versus Teradata. You just need to know join, and we're translating those commands for you. So that's one of the many ways we handle very large data. And yes, we do connect to Hadoop. You can write Spark and push the Spark, so the Spark lines of code are running in your cluster. So if you don't want it to run on your laptop, obviously you can push it to run in the Spark cluster. So all of those are options. A lot of flexibility to where you want to process the data and how you want to move it around. Great questions. In terms of, so Jing Chen asked, does Alteryx have an annual conference or events for a user community? So there are a number of things that we offer from a user standpoint. And I'll switch now back to the PowerPoint for a second here. Give me 1 second. And I think I had that. Hold on 1 second. Let me just see if I have a slide with that. I may or may not. Okay, I don't have one handy here, but I'll just mention we have a few different options for learning and events. So we do have a Southeast Michigan user group. So we have events in the area locally. This gives an opportunity not only to learn analytics, but meet other analytic professionals in the area. So we do have a user group, and you can get to that on our community site. And I think I have that website. See if I included that. There you go. So if you go to this website, community.alteryx.com, you will be able to find information about our local user groups, and you're always welcome to attend one of those. We do have an annual conference this year. We pushed it out due to, obviously, the COVID-19 situation, but we do have an annual conference, and we do them in every major region of the world. So in North America, we do one in Europe, we do one in Asia Pacific as well. So we do have an annual conference, but we also have many other opportunities to learn. So in our Alteryx community, we have a huge learning program, and I'll actually go to the site for a second. So on our community site, which will come up here now, there's an entire academy program with weekly challenges. This is like doing the Sunday crossword puzzle. These are great fun. You can pick a challenge. I'll go to the index first. You could pick a challenge that challenges you in an area you're interested in. So I'd like to learn about time series modeling at the intermediate level. I want to do a geospatial analytic. And so we can pick one of these challenges. And in the challenge, we provide you the data set. And you can try to solve the problem. And then you get to see how other people solve the problem. Everyone shares their solutions. And so it's like doing the Sunday crossword puzzle. Or you could take an interactive lesson, some of these videos, and watch any of these videos that you'd like. Or we have complete learning paths where you can train to do analytics. So we have a whole data science program, a whole getting started. So nice pathways to learn more about not only Alteryx, but really analytics in general. And so in these learning pathways, see what signs me in here. 1 second. Hopefully it'll log me in. In these pathways, we can learn how to do pretty advanced analytics using Alteryx at our own pace. So here you can see predictive modeling, data investigation techniques, creating a predictive model, etc. And then on the university partnership side, I heard somebody ask about that. Our Alteryx for Good program, give me 1 second, here. So in Alteryx for Good, we have a few different ways that you can learn Alteryx. So for students or educators, you simply come here. So look for Alteryx for Good. And if you're in an academic program, you're a student, you can click. If you're an educator, you can come into this as well. You simply apply. If you're a university student, the application, we do obviously an analytic process to check who you are. It happens very quickly. And then we grant you a license and access into the community. So very easy to get in. And then someone did ask the question comparing this to DataRobot. A DataRobot's a bit different in that it's very focused simply on, I'd say, the auto modeling piece of the puzzle. So, you know, you're not going to do your data preparation and blending and investigative stuff in DataRobot. It's more of an auto modeling tool. So, you know, we do auto modeling, but we do all of these other things. You're not going to send out automated emails with reports. You're not going to do geospatial drive time calculations and things like that. That's not what DataRobot does. DataRobot just does that very last thing that I showed with the auto modeling and the leaderboard, which I showed at the end is just one tool. That's basically what DataRobot does. So it's a bit different in that it's much narrower in what they are focused on versus the entire platform. And I think I answered all the questions. Any other questions? If not, we're just about at the end of the time. It was great getting to join the INFORMS team here. And nice to see some of my fellow Ford alum. Yes, we do have a certificate program. I see the question, do we have a certification program? And indeed we do. In our academy here, if you go to the interactive, or not the interactive lessons, the learning paths, I'm sorry. In the learning paths, we have a full certification program. So we offer certification. This is core certification. This is our data science certification. We offer these, and there's a test at the end. We try to make the test stress-free. You can take the test as many times as you want, as long as they're spaced out by 1 week. So hopefully a low stress experience. They're open book. They are challenging. I think you learn a lot taking the tests. But again, if my kids can pass them, I'm sure everybody on this call can pass them as well. We also have a program, if you know of anybody that's been affected by COVID-19, maybe have been displaced from the workforce, we have an ADAPT program for anyone who's maybe lost their job. We offer our training free for them as well. And so in this ADAPT program, they can get a key to Alteryx as well as all of the training. And we include in that a Udacity predictive analytics certification as well. So if you know of anybody in that circumstance, and this includes people who just graduated and maybe haven't been able to land a job due to the pandemic, we include them in this program as well. And one person asked the question, I think this is Jason, yeah, this is Jason. Without knowing the details of the methods used, how can one trust the results delivered from the process automation, the analytics? It's a great question. It's why for every tool on the palette, we show you the method that we use. Nothing's hidden. So if we're using an open source library, we tell you exactly what open source library we're using. Nothing is hidden. You can get in the documentation of any of these processes, kind of all the math is shown. So it is all very transparent, and that's one of the things that makes this a very powerful platform. It's a great question, though. In addition to seeing the methods for the tools, at every step of the process, if you click on the output, it shows you what the data looks like at every step of the process. So you can see, if I want to know just what is out of this left join, it says, hey, these are the countries that didn't match, that were in the top, that didn't match the bottom. And again, that transparency of every step of the process is part of what makes this a very easy to use, repeatable process that you can get analytics out of with integrity. It's a great question, Jason.
Okay, thank you, Alan.
Yeah, thank you.
Yeah. Are there any more questions?
So again, thank you very much for having me, Jason. This was great to meet the team here.
Okay, thank you again. And thank you everybody for attending, and hope to see you in our future events.
Super, love to come.